And now, when we talk about AI, the layer that we are building, that AI system itself is probabilistic. So, how do we make the entire system more reliable? If the funda or the system itself is probabilistic, how do you think it can be more reliable?
That's a very layered question. I'll try to answer it as best as I can. I think the first understanding that you need to have is the model is a very small part of the system. Oftentimes, people think that it's natural as a maybe as a researcher or as a data scientist or somebody who's working closely on integrating AI into your solution. It's natural to think that I need to spend more time fine tuning the model, generating better prompts, making sure that I get the last drop of outcomes from this model. But the system itself is much larger. And
We are at a crossroads in technology. Everyone is chasing the hype of AI, but very few are architecting the foundations that survive the next decade. Welcome to the Leadership and Learnings with Deepika. This is Deepika, your host. This space is about real conversations with technology leaders who are shaping the ecosystem, especially in the age of AI. And today we are joined by someone whose journey spans the technology ecosystem, from applied AI work at Intel and Qualcomm to translating deep research into real world scalable solutions. Please welcome the AI engineering leader and visual systems thinker, Mr. Sairam Sundaresan.
thank you for the kind introduction. That's very generous of you. I'm just happy to be here.
Same here. It's really excited to hearing from your conversation and your journey. So today we see that every organization they want to become AI native almost overnight, and I see as an architect that teams are rushing into pilots without thinking and without pausing, but the data integration, the system boundaries. So it is actually looking very promising in the lab, but when it actually hits the real world system, it's breaking. So, what is your perspective on this?
So I think a lot of it is driven by multiple factors. First of which is the peer pressure. So when you have your competitors releasing AI initiatives or pilots or more than pilots, when they actually are successful in the market, naturally the instinct is what have we done and why are we not there yet? And then you have the pressure of if it's a public company, then you have the pressure of the shareholders, or if it's private, then you have the pressure of the investors. And on top of that, there's also a lot of misconceptions that AI is just something you tack on and it'll just work out of the box. Oftentimes it may not even be needed, and sometimes it feels like it's done so that you could secure funding, or something for a namesake versus something that's thought through holistically. And part of the reason pilots fail is because most times in your labs you're simulating with maybe better than average conditions, more closer to ideal conditions, whereas the real world is very harsh. You don't know how users will use your tool. They'll find new ways of using your tool that you wouldn't even probably think of. They may there might be exploits, there may be security violations, there may be n number of things that happen. And this was true even with traditional software, let alone AI. And the disadvantage that you have is that AI isn't predictable, right? It's a probabilistic model. And as a result, now not only do you have challenges from how your users adopt and use this product or tool that you have released, it also means that the model may not behave in the way that you thought it would. Maybe you would have simulated as many corner cases that you thought were feasible or possible in the lab, but
Right.
what really happens in production is completely different, something that you didn't think of. And when that happens at scale, then you're dealing with a crisis that has to be rolled back and handled very effectively. So that's just a few things that I've seen happen around, especially when everyone wants to use the next latest and greatest innovation that's coming out of the frontier labs.
Coming from engineering deterministic systems, when I talk about rules based or the traditional SQL, and now when we talk about AI, the layer that we are building, that AI system itself is probabilistic. So, how do we make the entire system more reliable if the funda or the system itself is probabilistic, how do you think it can be more reliable?
That's a very layered question. I'll try to answer it as best as I can. I think the first understanding that you need to have is the model is a very small part of the system. Oftentimes people think that it's natural as a maybe as a researcher or as a data scientist or somebody who's working closely on integrating AI into your solution. It's natural to think that I need to spend more time fine tuning the model, generating better prompts, making sure that I get the last drop of outcomes from this model. But the system itself is much larger. In fact, many years ago, I don't remember the exact date. There was a paper that roughly benchmarked this at the model being 5%
Yeah.
of the total machine. But basically, the point was that the model is roughly 5% of the entire system. And if you spend 90% of your time trying to optimize the 5%, naturally things are going to go south. And the way that you build reliable systems is, again, understanding that when you don't have something that gives you deterministic outcomes, you need to account for how to handle those situations gracefully. And that comes, natural answer is guardrails. It means that you add more defensibility. You add, these could just be heuristic checks and things around the model that prevent it from behaving in a certain way or handling unexpected results. It also means that you have to handle situations with, like, for example, let's take you're working with an agentic solution. And in
Mm-hmm.
an agentic solution, let's assume that your agent has to do the planning and it's stuck in a loop.
Okay.
There's no way for you to know that it's stuck in a loop and like burning through tokens and API credits for you, unless you have like your traceability at every layer of the system, unless you log everything, and unless you understand that if there are multiple possible ways of you know uh, tying a bell to the cat, so as it were, you need to be aware that the way that you think the agent will do something is not the way that it might end up doing things. So basically just being extremely paranoid about how the system operates, incrementally adding or incrementally giving it affordances, meaning more and more flexibility to do things once you're sure that the you can predict the behavior reliably, and doing that in a very slow and scaled way as opposed to just unleashing everything at once. Those are just some basic ways to handle it, but then of course with every application you have different constraints you have to think of.
Yeah, thank you, Sairam, for that. So when you say that you need to have guardrails in place and then constraints and these things in place when to think of that reliable. But however, when I think of these legacy systems, so there is a lot of traditional 20 years of legacy code, and we are trying to add an additional layer on top of this, like that AI layer. So are we not setting up ourselves for that failure at scale?
Generally, what I've seen across the industry and heard from colleagues and friends is that when you deal with introducing AI into a brownfield problem, which is an existing legacy code base, it's much harder than using it for a greenfield problem. It's also the similar reason why, if you think of a startup that is trying to build a AI powered feature, and incumbent that has used legacy systems in the past trying to modify that feature, that existing feature it already has, to use AI, that's where you'll see like this play out quite profoundly. Like one example is, if you think of email clients, just imagine a startup that's trying to do AI powered email. They'll approach it in a very different way. Whereas if it's an incumbent, then you probably think they'll be adding an assistant somewhere in the middle, because there's so much of legacy code
Exactly.
that will break, right? So um, it's a much harder problem, and therefore it requires time and care, and sometimes you really need to decide whether it's the right thing to do. Sometimes it might
Okay.
like certain features might be better off rewritten, but those are decisions that really need thought and care, and not something where you just say, okay, I'm just going to add another layer and I'll add guardrails and things will work. So it's case by case, and as with all AI use cases and applications, the answer is always it depends. I know it frustrates a lot of people when we say it depends, but that's the reality.
Okay. So I think to the listeners, this is a very powerful takeaway. And once again, Sairam has re-emphasized that point that when we are building something on the legacy systems, adding this AI layer, we need to be really mindful of what we are building, because it's not just adding these plugins.
Yeah, yeah.
Like,
So basically the point is you shouldn't necessarily think of it as I will just use AI as a layer on top of an existing system. It might be the right solution for your use case. It might, after a lot of consideration, if you feel that that's the way to go, that's so.
so I believe this is my powerful takeaway and a reminder from Sairam one more time. And with that, so how do you evaluate these LLMs when, because there is many LLMs, and I mean when I say LLMs, not the traditional models.
Mm.
So we have a lot of them. So what is that? How do you evaluate them before we actually take the model? Absolutely, I agree with you when you talk about, when you say that model is a very small bit of it when we build the entire application. I totally agree with you on that. So before actually taking that model or choosing that model, how do we evaluate the accuracy of the model?
Depends on the application, right? So and also depends on your budget, depends on the compliance and other factors that are in play, because certain companies are not allowed to use external.
So based on this, do you recommend any resources or any books for us to understand it high level more and then go into the deeper understanding of these terms, and not the terms, I would say, to gather more knowledge on this
So
while implementing it?
generally, sure. I think that it has to start from where you work in the pipeline, and depending on that, your needs are quite different. If you are using existing models and building applications with them, of course, Chip Hoyen's famous book AI Engineering is a really fantastic resource. It's pretty well detailed and walks you through all of the necessary things. If you're working on fine tuning the model and those kinds of things, there are many books specific to those. I mean, I think there's a like a there's a I forget the title. I'll try to recall, maybe share it with you after
Sure.
the show. But I think it's something like an AI engineer's handbook or something that will talk about those aspects. And then if you really want the nitty gritty of training and the what happens inside language models, then there's a book called Hands-on Large Language Models that you can read. So those are three books that cover the space. And then if you want to go one step before, like the fundamentals of machine learning and everything, there's another book called Hands-on Machine Learning, which I highly recommend. And oh, I forgot another book by Sebastian Rashka, which is building a large language model from scratch. So those are all the books I can think of. In terms
Okay.
of video resources, of course, there's one by Andre Karpathy, which is I think Neural Network Zero to Hero, which covers like in a
Yes,
span of two
yes.
hours, covers a tremendous amount of ground, and that's something that I highly recommend. So just using a fraction or a mix and match of those alone will get you a long way.
Sure, Sairam. We would love to explore that book. So, because you were talking about the math and the fundamentals, so now if you see, the AI has it's a low code, no code, and it can write complex codes. So pretty much all the pure coding has been so much standardized. So, what are you predicting in the future? Do you think there is scope for these young engineers, like to all the engineers watching this? What is that one advice you want to give to all of them in the future? Do you think there is scope for these engineers who can connect systems and then domains and then understanding it the high level picture, or should they focus more on these math fundamental problems or the pure coding? What would you?
The suggestion I have is just focus on the areas where you can have outsized impact and where your skills are already strong. Double down on those, and then pick one other area where you can have something that you're interested in that's related to your function, and then
Sure.
also really go into that at a deep level, like Cloud Code, or things like that that can help you work through some of those deficiencies, whereas you can focus on spending your time on what you're already good at. So that would be my suggestion.
Sure, Raj. And with that, we can close the session for today. And to all the listeners, once again, thank you so much for being part of this journey. And also, I would like to thank Sairam for sharing such insights and his AI journey and fundamentally driving the AI driven systems. And thank you so much, Sairam, for once again for being here.
My pleasure. Thanks for having me.